Right, guys. So the next part I want us to go to is the pH of a base. Okay. So we've been looking at how to calculate the pH of an acid. And we said that, remember, the formula for pH wants us to have the concentration of the hydrogen ions or the concentration of the hydronium ions when we're calculating it. But now I'll show you how this formula comes in very soon. Because when you look at a base, every time I've been saying for an acid, you need to look at how an acid is going to ionize. Because that acid is going to give you hydrogen ions. And that's when you then calculate the concentration of your hydrogen ions and put it into the formula. But with a base, if you look at a bases dissociate. So if you look at this sodium hydroxide, it would dissociate into sodium plus hydroxide ions, right? Cool. Now, we're used to saying, okay, cool, we've got a concentration of our base, which is 0.2 moles per cubic decimeters, and what we need is to do a concentration ratio. But if you're doing a concentration ratio here, you will be doing a concentration ratio for sodium hydroxide to hydroxide ions, because that is what your base dissociates into. Your base does not dissociate into hydrogen ions. Remember all those terminologies that we learned from Laurie Bronsted and Arrhenius? Your base will dissociate, but it will release hydroxide ions. That is what we see here. So when you do a ratio of 1:1, what you're actually finding in this case is you're finding your concentration of hydroxide ions. So once you find your concentration of hydroxide ions, which is 0.2 moles per cubic decimeters, you do not take that value and then put it into this formula, because remember, that formula only wants the concentration of hydrogen ions. What we need to do is to then find that, okay, if we've got 0.2 moles per cubic decimeters of hydroxide ions in our base, that is where now this formula comes in for the ionization of water. This formula gives you a link between the concentration of hydroxide ions in your base as well as the concentration of hydrogen ions from water. So because you have your concentration of hydroxide ions, what you can do is, using this formula, you can then find what the concentration of your hydrogen ions is. Because what this formula is basically saying is it's saying hydroxide ions multiplied by hydrogen ions to get the answer. All right. And now if you go and you calculate this, you'll get a value. It will tell you that the concentration of your hydrogen ions will be 5 times 10 to the power of negative 14 moles per cubic decimeters. Now you can take that value, and that is what you plug in to the equation over there. So what you get for your formula, you have to say negative log 5 times 10 to the power of negative 14. And after that, you will be able to get your value for your pH. And remember, guys, this is a base, right? And what do we remember about bases? Bases will have a pH between 7 and 14. And guess what the answer is here? 13.3.